Hi guys, welcome to the next lecture. I'm hoping that we can start and create a couple of lessons. I've got some code here which will act as a guide for what I want us to work with. So based on this code, I want us to make pretty much 1, 2, 3, 4 projects that I'll explain each and every project as we go along. So I think the shortest project that we can actually make is called a register. I decided to do a repeat of some of the things that we would have done. It messes up the order a bit, but we can still be able to build from where we have worked, or the things that we have worked on. So I wanted to call it register, so maybe let me just copy register as it is typed there. That's the name of the project, and I'll just explain what a register is. So pretty much what this then means is it's part of our data types, and our data type register pretty much means we'll be able to use the keyword register for whatever it is that we want to actually work with. So here's the code that is there. I'll just look at it, and in fact I'll just pretty much change it a bit. This is what we've got, and we declare it as follows. We simply put register, we then put the data type, and then we put the variable name, which in my case I can put it as num is equal to 0. So what this then means is we register this in memory, so that our memory actually knows that there's a registered integer that is called num1. At the same time, we then want to be able to display the contents like we've got there, where we put a for statement and we put a printf statement, and we have stuff outside of the printf statement. So this pretty much means we want our loop and we want our print to actually happen. So we have a for statement, and then we say num is equal to 0. We put a semicolon. We then say num is less than, we have 2 there, so let's actually push it up to 5, like that. And then we also say num iterates, so that it iterates from where our num is. We can also then display the contents of num. So we say num, we put a colon, we put a %d, we then put a new line like that. So we can actually run our project as it stands, and we'll then get the following. Oh, the reason why we're not getting any numbers is I didn't put a comma and our num, so that we actually point to the value that num will be at any given point in time. So if I then do it that way, you actually then get to see that register on line 6 pretty much gives us a reference point to say we want to register in memory and allocate an int value for num where we actually started 0. Then our for statement pretty much gives us a guideline of where we want our value for num to actually range, so that's 0 to 5, and then num plus plus simply means we're adding 1 at each iteration or each increment that we've got, and then we can be able to display what our num does. So that then becomes our project on register. The next one we actually want to do now is the next one, which is this one, which is on static. So we also want to work with a data type static, where it still pretty much modifies our existing data types, but we're actually just now going to add static to the existing data type, so that we can be able to see how static works. So in this particular instance, we've got our code as follows, which is this one. But I think for it to make sense, it wouldn't make sense for me to just copy this and then put it there. I would actually need to create each stage with you and then explain why each stage is like that. So here we've got this code as it stands there, but I actually want to modify the code a bit so that we can see how each element works and how we can work with the element. And if you remember, in one of our lectures we said this is actually having a function prototype. We call this a function prototype, like that, but we don't actually want to work with it. So what we want to do is we want to create our function. We want to have the static variable actually created, and then we actually want to increment the value of count. And then that value of count is what we will then pass within our loop so that we can actually have that running. So let's actually do it this way. I will change the code as follows. So we'll have a void, and then we want a function that will actually use our static. So we'll say our function is use static, like that. Doesn't have any parameters within it. And we then want to actually see how we can use our static. So we can say static int, and then we call num, which becomes our value, like that. So based on this, we also need to initialize our value to equal to 0. So num is now equal to 0. And then at the same time, we want to iterate the value of num. So we say num plus plus. In this case, we're actually using count. So we actually want to change it from count to num plus plus. And then we want to be able to print what that value is based on our code. So we then have a printf, and our printf should give us the following. So num equals %d, we put a new line, we put a semicolon, like that. So what this then means is we want to be able to call this in this particular instance. But in this instance, we also need to define our variables. We need I, and then we need, let me just copy my for statement as it is, because it's literally not going to change. In my for statement, I have that, and then I would need to call on use static, so that we actually work with static, which is our function. And then if I run the program, I should be able to get the contents. Yes, the contents are now coming out, but I forgot to do what I did in the previous lesson, where I was supposed to just put comma num, like that. And then when this then happens, I can now be able to actually view the contents of my use static. So in essence, what we are saying is we have created a function called use static, and our use static has a static value, which is actually num, and that is equal to 0. And we want to be able to increment the value of num at each iteration. But to iterate our static, we need to actually then be able to be in our main and within a loop. So we then can simply state that our I would be equal to our num, and then our num would then be iterated because of the for statement 10 times, which then gives us the values from 1 all the way up to 10. And if you actually take note, we don't start displaying our contents from 0. We actually start displaying our contents from 1. So in other words, we're then saying from the starting point of the content, we have already added 1. So by the time we actually start printing, we're actually starting from 1, and then instead of ending at 9, we actually end at 10 because we're saying 9 plus 1, which gives us 10. So that's pretty much how we work with our static variable. Although I think I'll need to have supporting nodes for register and static so that it becomes a little bit easier for you to understand and master. The next thing that we actually want to work with as well, it's still part of our variables, but will now link to what we actually worked with on structures, or it'll be similar to our structures. The two projects that we actually want to work with, the first one would be a enumerator. Okay, enumerator pretty much is a type of a structure, if I can put it that way. It's a type of a structure in that it works more or less in the same way as our structure. The only problem now is we're actually referencing a position within our enumerator. So the position that we're referencing will then be able to actually display whatever is stored at that particular point. So if you look at the code that I've got here, we are saying enumerator computer, where we have a keyboard, CPU, screen, printer, and mouse. Int main, where enumerator computer, then comp, which is something similar to what we have seen in structures, and then comp equals to CPU. This actually gets the position of whatever it is that is in our comp. And then we have a printf %d, we then get our comp, which pretty much gives us a position for whatever it is that we want to work with. So for my example, I will still work with this, but I will redesign the enumerator to have something else. So let's say our enumerator is as follows: enum. If I spell it wrongly, it will not show. So we say enum direction, like that, where our directions should be as follows. Okay, I think we need to put equal to. No, there's not equal to, it's just the curly brackets and then the content. Yes. So we then do the following. We want direction. So the first direction is north. The next one is south. The next one is west. The next one is east, like that. I hope I didn't make an error. Okay, that's how we actually do it. Perfect. So we're on track. So after this, we then put our semicolon. So this is where it becomes different from our structure, in that the keyword we've got here is enum, like that. And then we've got the word that we actually want to work with, which is direction. And then we've got north, east, west, and south. I think I got my brackets wrong here. They're supposed to be curly brackets. Okay, like that. And then we then want to use this in our document. So we then have enum direction, and then we need a identifier, which we have put there. So our identifier in this case can be choose. Okay. So if we want to choose a direction, we then need to have choose and give us a direction. Okay. In this particular case, we had actually said comp is equal to CPU, which gets the CPU, and then we can print the contents of comp. In this case now, we can then say choose, which is our direction, and then we say that is equal to south. Okay. And we can then be able to display the contents of choose. So we have a printf, and our printf pretty much gives us the following. The direction is, we put a %d, we put a new line, and then we put a comma, and then we put our choose, like that. So what this then means, if we run it, we'll then get 1 as our position. So this is the direction is 1, and 1 gives us south, which is at that particular point. So this then gives us what our enumerator pretty much does. So we might also need to add notes to our enumerator, in that we are then saying how we actually declare it. We simply put the keyword enum, we've got the definition, which is direction, and then we put our curly brackets on the edges of the text. Then each element we actually denote it by a comma. So north, south, west, and east. And then we've got our semicolon. So this then means that is our enumerator. From there, we then call it within our main function, where we are saying enum, direction, and choose. Then choose equals to south, which is a property of what we've got in our enum. When we then display it, we actually just display the position at which we are looking at. So that pretty much means we are done with how our enum works. The next and last element that we actually want to work with is a union. And our union is pretty much the same as a structure, only under a different name. I'm not sure why the developers of C pretty much did this, because we are going to actually see that it's exactly the same as our structure, only a different name is then used. So we say union, and with our union we then call it marks. Okay, and as you can see, the only thing that has changed from our structure is just that union, but everything else remains the same. We can then say we want, for example, character, grade. Okay, we can then also say int mark, like that. Okay, so we've got the grade, we've got the mark. Maybe we can add one more, which can be percent. Okay, we've got grade, mark, and percent. Those are the two elements that we actually want to work with. So as we get to our main, we want to be able to call this as well. So you simply say union marks, and then we say an identifier can be sum, sorry, for lack of a better one. Okay, and then now that we know that we've got this, we can actually now be able to reference sum dot grade equals, we put whatever we want for our grade. Outside of that, we say sum again dot mark is equal to 55. Okay, and then sum dot mark is equal to 50. Okay, so we can simply say that this is what we would have created. We've got grade, mark, and sum. Okay, I'd actually not seen that here. I'd made a mistake. So this is actually supposed to be percent, like that. So now we've got the grade, the mark, and the percent. Okay, where we can be able to also just view these elements as follows in our simple printf, and we can then say grade percentage %C and mark. Our mark is a percentage %D, and our percent is a percentage %D as well. So given that, we then also need to just put these values, sum.grade, sum.mark, and then lastly sum.percent, like that. If we run this, I forgot, or rather I put the wrong delimiter. Okay, so now that this is done, I can actually see that my grade is giving me a 2 there. My mark is giving me a 50. My percent is giving me a 50. Okay, so there could be some logic that I messed up. I can't seem to see where I messed up. Although now we are getting the right order that we want. We're supposed to then say our grade is equal to that, which we've got sum and grade. That should be fine. Our mark, which should be 55, we're getting 50. And our percent, which should be 50, so that's okay. I'm not sure what's happening with the first two, but that's pretty much how we're supposed to get our content. Or rather, let me just try one simple thing. I think I might know where our error is actually coming from. Let's see. Let's just try to put one element, which is our grade, like that. We close the project and we run it. Still giving us 2. So there should be something else that's missing. Character grade. Let's see if we got a small. Let's just see. Still giving us 2. Okay, I'm not sure what the error could be, but it's supposed to just give us these values. So that should be something in my logic, something along the lines of my logic. But this is pretty much how our unions work. So we've done a register, we've done a static, we've done an enumerator, we've done a union. Please do ask questions if you've got questions. And if there are any suggestions, I can make corrections of some of the elements I would have made errors on whilst we were in the lecture. But here ends our